Hello and welcome to the video on simulation. I'm going to warn you, there's a lot of writing on this video. I figured I would do this, so this would kind of serve as notes and I'll write through here, okay? There's a lot of steps, okay? I think 7 steps to simulation. So we're going to go through these steps fairly quickly to shorten this video up. Okay, so let's get started. Simulation is the process of imitating a real life event many times. So, what that means is there's some stuff in life that is just hard um, to reenact. So what we do is we use a computer to simulate that event, and then we record a bunch of what we call components, which makes up a trial, and then we do a whole bunch of trials and record. Okay, so let's talk about the steps, and the first one is the component. Okay, so this is the building blocks for simulation. Okay, so I got an example. We could talk through this example, and well, here's the example up here. So we're interested in simulating the number of boys that a woman will have if she has 3 children. Okay, so she has to have 3 children, 1, 2, and 3. Okay, so when we get done with those 3, we're going to count the number of boys. So I'm looking for the number of boys out of these 3. Okay, so what the component is one of these. Each one of these is a component. Okay, each one of these is a component. All right, now if I look at it and I say, okay, well, this one component, let's just say this was a boy. Okay, this is not what I'm interested in. I'm not interested in just one of the boys. Okay, I have to see what happens. I have to see what happens after all 3 of the components are already done. Okay, and depending on the situation, you could have 100 components. You could have 10 components. It just depends. Okay, you could have infinitely many components. Okay, um, not often, but you can. Okay, so if we simulate one sequence of components, that is considered a trial. That's very important. These words are important. If we if we do a sequence of components and we end, that's a trial. So here's 1 of the sequence, 2 of the sequence, 3 of the sequence. So once I do all 3 of these, that's considered a trial. So in this case, um, one trial is having 3 kids. Okay? The result, the trial's result, is called the responsive variable. That's what we're interested in. The response variable. Okay? So in this case, what's my response variable? It's right here. That's my response. Okay? That's what I'm interested in. The response variable. Okay? The number of boys and 3 kids. That's important, and the 3 kids. Okay? So here, that's the first thing you have to do. You have to identify the component. Okay? A trial is made up of many components. So the first thing you have to do is you have to identify this component. The next thing you have to do is you have to explain how you're going to model the component's outcome. This outcome. So to do this, you have to know the probability or the chance of every single outcome. Okay? So if you read this, the component is the basic building block of simulation. We must be given the chance of the outcomes in the component or of the component. Okay? We have to know the outcomes of the component. So the outcomes here, the 2 possibilities are a boy or a girl, and I give that to you. I say, okay, so the component is a woman having 1 child, right? Which has 2 outcomes. If the chance of having a boy and a girl is 0.48 or 0.52 respectively, that means that this matches up with this and the girl matches up with this. So you're a little bit more likely to get a girl than a boy. Then one possible way to assign numbers to each outcome is, okay, here's where it gets a little tricky, okay, is assigning to numbers to components. You have to assign numbers to outcomes outcomes of a component. The component's not going to change. The component's just one thing. In this case, it's having a kid. Okay, so look, this is where it's not really tricky, but what's the chance? It's a 48% chance. So we always do things in hundreds. Okay, we always want to do these percents in hundreds. So if I took 100 numbers, okay, because that's how many numbers I'm going to pick from. I'm going to pick from 100. If you have 100 numbers, how many numbers need to be for boys? If there's a 48% chance, 48 numbers need to be for boys and 52 numbers need to be for girls. So if I start from 0, 0, which is one less than 9, then I'm going to go up to, if I'm using the random digit table, then I'm going to go up to 47. There's 48 numbers here. So if I take all these numbers and write them on a sheet of paper, 0, 0, 10, 15, dot, dot, dot. If I put all these numbers and put them in a sheet of paper, and I put these second numbers, there's 52 numbers there. From 48 to 99, there's 52 numbers. And I put all these numbers in here. I put these numbers in here, and I put those numbers in there. Okay, and if I reach in there and pull one out, what's the chance it's going to be a girl? Well, there's 52. There's 52 girls out of 100, so it would be 52 out of 100, which is 52%. What's the chance it's going to be a boy? Well, there's 48 boys in here, so you have a 48% chance. 48 of the boys out of the 100. Okay, so hopefully you get that. The calculator's a little easier. Okay, you could say, okay, I'm going to use my calculator, and you're probably watching this video later, but as a matter of fact, I'm recording this the same day that I pulled you up the class to read the assignment on the interesting data for the class. Hopefully you'll laugh at that. Okay, so you guys came up and gave a little spiel about stuff that's interesting. Okay, and I won't name a kid in my 7th hour who put a female down for himself and thought that was interesting, which I thought was interesting. And he'll probably never watch, but anyways, random integer. Okay, I want to 1, 100, and and 3. Okay, that's how you would do this. You're gonna get a number from 1 to 100. If the number is 0 to 48 or 1 to 48, it would be a boy. 49 to that. Okay, so for example, it could come out like this: 10, 52, 96, something like that. So this would be boy, girl, girl, boy, girl, girl. That would be one trial. That's one trial. One trial. What's the response I get? What am I interested in? The number of boys. So the response for the first trial, okay, I'll call my trial x. x1 is equal to 1. Okay, this is data just like we collected from chapter 4. Okay, quantitative data. Okay, this is probably the toughest part. You get a component. The component has outcomes. You have to assign numbers to the outcomes. You have to explain how you're going to do it. Okay, step 3. Okay, explain how you will combine the components to model a trial. Describe how you will pick the numbers to simulate a component until the trial is complete. Explain when you will stop simulating components. Okay, so what you have to do is you have to describe this specifically how you're going to do this. So using a random digit table, if you do that, I will select a number from 0 to 99. Okay, that's the start. Each number selected will represent a baby being born. So I'm describing what the component is. Okay. If the number is 00 to 47, it's a boy. If the number is 48 to 99, it's a girl. I will repeat this 3 times to represent 3 babies being born. Very specific. Okay? So this is an important step. Clearly state the response variable here. For number 4, clearly state the response variable. This response variable is the result you obtained from one trial. So if you have 3 kids, it's the number of boys you have. Okay, it's the number of boys out of those 3 kids. Okay, these are your possibilities. Okay, you could have 0 boys, 1 boy, 2 boy, or 3 boys. Run several trials and see what happens. Okay, so we need to run several trials. So let's jump right into this table, and I'm going to start from row 1. Okay, the first number is a 96. So I'm looking at this. I have this down here. Here's my numbers, just to remind myself, 48 through 99. So this is a girl. That's one component. The next one's 29, which is a boy. That's my second component, or another component. And then I have a 90, which is a girl. So trial 1 is equal to 1. 71 is a girl. 96 is a girl. 98 is a girl. So x2 is equal to 0. Okay, I'll do one more. 64 is a girl. 22 is a boy. 20 is a boy, and 6 is a boy. So I'm going to circle my trials. That's a trial. That's a trial. And this is a trial. So on my third trial, I got a 3. Okay? The more trials obtained, the better the results. Okay? The better the results. Okay, so you're going to keep doing this. Or what I'll do is I'll do 10 of them. Okay, and then I'll be back. I'll pause it and come back. Okay, I'm back with a calculator on my screen. Alright, now look, I got my 10. These are my 10 data sets. If I was gonna graph this thing, I would do a dot plot. But let's go to the next page. Okay, collect and summarize the results of our data of all of our trials. Describe the, okay, if you remember this is our shape. Are there any possible outliers? The center and the spread. Okay, so I have my data in here. A histogram's not going to do me that much. If it was me, I would do a dot plot, and my possibilities are a 0, a 1, a 2, and a 3. So let's take this. How many zeros do we have? We have 1 0. Went the wrong way. We have 1 0. Remember, making dot plots, make sure you stay really horizontal. That again. Okay, how many ones? That's 1, 2, 3, 4, 5, 6 ones. 1, 2, 3, 4, 5, 6. I'll do the best that I can. How many 2s? Oh, was there a 3? A boy, boy, boy? There wasn't no boy, boy, boy. That's something's wrong with that. That's 1 boy. That's no boys. This is 2 boys, not 3 boys. So how many 2s do we have? 1, 2, 3. One, 2, 3. Okay, so not that interesting. But the reason it's not that interesting is because there's only 10 trials, just because of time. Okay, so we're also interested in the spread. So stat, calc, enter, and the average is, okay, the average number of kids that shall have over 10 trials is 1.3, with the standard deviation of 0.82. Okay, there's no really possible outliers, so you'd want to describe this. Okay, and here you would just state your conclusion. The mean number of kids a woman will have is about 1.3 boys per 3 kids. The number of kids a woman will have is about 1.3 boys per 3 kids. It doesn't sound that great, with a standard deviation of 0.82. I don't see a whole bunch of interesting stuff here, other than most of the time they'll have 1 boy and 2 girls, which I guess could be pretty interesting. Okay, you also could say none of them had 3. But just remember, if you're ever doing this, for the most part, you're going to have more than 10 trials. Okay, so you could get more out of it. Okay. So, anyways, I'm going to do 2 more examples without all this work. I'm just going to go right into it, give you a situation, and do it. So, um, make sure you watch those because simulation could be sometimes it could be pretty difficult. All right. Have a nice day.